Hello, everyone. It's great to be with you. My name is Randy Booten. I'm the general manager of AWS DataSync. Today, I'm joined by Miriam Belhaj, senior solutions architect, Wave, and Eric Durand, product leader from our Snow family. And today, we're going to talk about some best practices and considerations when you're moving large amounts of data to AWS, either through online methods or offline. So for an agenda, we'll start with a data migration overview. We'll then move on to some considerations between online and offline, some of the things you should consider when you're weighing the value of each. Then we'll dive into an AWS DataSync overview. We'll then move into a Snow family overview. And we'll finish the session by bringing both of these technologies together and show how you can leverage both in combination. So first, when you think about large-scale data transfers, we're really talking about tens of terabytes, hundreds of terabytes, even petabytes of information. This is millions of files. And when you consider doing something like that on your own, there's a lot of challenges in moving that much data. First and foremost, you have to start building and managing your own scripts, right? So that becomes a burden, an operational burden on you. You also want to make sure that your data is secure. So how do you encrypt your data? How do you verify that the data you transfer actually bit for bit made it? And something didn't happen on the course to its final destination. And also, you want to deal with network errors and retries in the network. Data movement of this size takes considerable time, right? This could be weeks or months of activity. And during that time, you're going to see performance challenges, interrupts, and how do you deal with all of this? So it becomes very challenging when you're talking about data at this magnitude. So AWS has a broad portfolio of services that can help ease your migration challenges. First and foremost, there's online with AWS DataSync. There's offline methods with AWS Snow family. We have tools for application migrations, also database migrations, and also tools that help you manage some hybrid storage. So if you want to keep your applications on-prem, but you do want to have a lot of that storage up in the cloud, we do have the AWS Gateway family that allows you to work effectively in a hybrid configuration. But today, we'll focus on AWS DataSync for online and AWS Snow family for offline. So when you're thinking about online and offline, one of the first things you need to think about is your available bandwidth. And the key word there is available. You may have, your company may have strong network available or strong connections to the internet, but the question is how much of that's available to you for this migration exercise? And do you want to allocate that much of your bandwidth for this activity? That's a key consideration when you're considering using something like DataSync to move your data online. There's also firewall considerations. This data is going to traverse your network, and there may be some ports and changes to your firewalls that you need to make to accommodate it. And you want to make sure that you have the ability to make those changes and facilitate the move. And one of the upsides of an online migration is that immediately once that data hits the AWS storage service, it's available for your use, right? So you can take advantage of that data landing quickly and leverage that for the value that it represents. When you're considering offline, now you're talking about networks that are spotty or very constrained, and moving data over the wire just doesn't make sense or it's not a possibility. Then we have our Snow family of products, and these are physical devices, physical drives that get sent to you. right? And when you're taking advantage of that, you want to make sure that you have, one, the personnel to receive these devices. We're going to mail them to you, in effect. You have to have the rack space or the data center space to house these devices, and the ability to move your data onto these devices. But after that device needs to be sent back to AWS. So there is a time consideration, where online it's instant, near instant. Offline is going to take a little bit of time, and you have to understand the implications of that and make sure you're okay with that. So here's a table that I think is helpful. It tries to capture the time to transfer for online moves. So here you see on the left, we've got various sizes of data to be transferred. And across the top, we have various bandwidth available. And you can see, if you look at the 10 petabyte example here on the bottom of the table, if you have a strong 10 gig connection to the internet, you can move 10 petabytes of data in 116 days online. All right. Whereas if your network starts to fall to the left of that, the 1 gig, the 2 gig bandwidth, you start to see that moving 10 petabytes could take 4 years online. Right. So that becomes untenable in many situations, and that's a great area to start consider offline. Start using our Snow devices in areas such as that. Okay, so let's dive a little deeper into AWS Data Sync. We started the conversation talking about some of the challenges you'll face if you tried to embark on this move on your own. And we built Data Sync to address many of those challenges for you as a managed service. So what is AWS Data Sync? AWS Data Sync is an online migration service that enables you to easily and quickly move your files and objects to an AWS storage service. It's fast, right? We've built AWS Data Sync with a custom-built parallel protocol that speeds transfers. It's easy for you to use. It's secure and reliable. So all of the data in flight is encrypted. We also support encryption at rest as well. There's also capabilities within the service to deal with resiliency around network drops and retries. Right? We handle all of these network challenges for you. Data Sync is a fully managed service. So we'll handle all of the heavy lifting that will connect you to the AWS storage services, all the networking in the back end. We take care of that for you. And AWS Data Sync is cost effective. The cost for the service is 1.25 cents per gig with no minimum for that. So when we talk to customers, there's several use cases for Data Sync that start to appear. And the first is migration. So many customers are looking to move their applications to AWS, and many of those applications rely on unstructured data, file object data on-prem to enable them. So you want to move that data up into the cloud as well to give your new cloud app access within the cloud. So migration is a critical use case for us. Data Sync enables that. We also have customers that over the years have accumulated a number of files and objects that have just become cold, infrequently accessed, and really just taking up data center space, storage space on-prem. And they want to leverage the cost-efficient storage options in AWS, such as S3, Glacier, and so using Data Sync to move that data up into that cost-effective storage becomes very appealing. Many customers fall into this use case. We have other customers that choose to keep their primary apps and data on-prem for whatever reason. There's compliance, there's other reasons, and they use the cloud for business continuity and DR. right? So they'll use data sync, which can be scheduled to run and execute incremental transfers to keep your storage that's on-prem consistent in the cloud. So that's a very efficient business continuity or DR use case for you. And lastly, we have customers that have business workflows where they have devices on-prem, medical devices, that are producing data that they then want to lift that data, get it up into AWS, leverage AI or ML processing, and then bring those results back to on-prem as part of a consistent workflow. We have many customers leveraging data sync for that as well. So to dive into what you can do at a further level, I'll introduce Miriam to take us another level deeper.
Thank you, Randy.
Thank you.
Thank you. And as Randy already explained, you can use AWS Data Sync in 4 main setups. And the first one, and the most obvious, is to use AWS Data Sync to migrate your data from your on-premises storage system to AWS. And here you can think about your NFS or SMB file shares that you need to migrate, or maybe you have an object store system that is compatible with Amazon S3 API, or maybe you want to replicate some data from your HDFS cluster to AWS. So in all these cases, you can use AWS Data Sync to move your data into AWS. And in addition to that, AWS Data Sync is present at the edge. So for example, you can use AWS Data Sync with Snowcon devices that Eric will present later. So this device is shipped to your data center with an AWS Data Sync agent already pre-installed. And we have customers, for example, automotive customers who use Snowcon devices into their autonomous vehicles, and they collect data from their for telemetry data. And once they finish the testing, they go to their autonomous vehicles, get back the Snowcon device, and go to their office, plug it into their network, and activate the data sync agent to start moving the data directly from the Snowcon device to AWS without having to ship back the Snowcon device to AWS. Another use case is using AWS Data Sync to move data from your Amazon S3 buckets in AWS regions to your Amazon S3 buckets on Outposts. And Outposts provides storage and compute capabilities at the edge. And the experience that you have with Amazon S3 on Outposts is similar to the experience that you are having with Amazon S3 on AWS. In addition to that, you can leverage AWS Data Sync to move your data from Google Cloud Storage or Microsoft Azure files to AWS. And our customers might use that to share data with their customers, providers, or partners who are already using either Google Cloud Storage or Azure files. And finally, our customers might want to move data between AWS storage services. So for example, if you need to move a subset of data from your Amazon S3 bucket after it has been processed, you can use AWS Data Sync to move it from this AWS bucket to another one. In addition to that, if you have archived data on your Amazon Elastic file system that you want to move to Amazon S3, you can use AWS Data Sync to move this archive data to the Amazon S3 archive storage classes, such as a Glacier Flexible Retrieval or Glacier Deep Archive. So to summarize, AWS Data Sync supports moving data between all the storage services that we provide or that we support. And sometimes when we discuss migration projects with our customers, they struggle to know how their on-premises storage systems are used in terms of capacity or performance, and they don't know which AWS storage service they need to pick up. And that's why we recently launched the public preview of a new feature called AWS Data Sync Discovery. These features helps our customers plan and implement their data migration into AWS. So this feature allows you to collect data about the usage and performance of your on-premises storage services. And once this data is collected, it will be analyzed and generate automatic recommendation for you to know which data you need to move and which AWS storage services you need to use to fulfill your needs. So this feature is really helpful for our customers and makes them accelerate and reduce the costs of their data migration into AWS. So now let's go back to discuss to dive deeper into how you can use AWS Data Sync to migrate your data from on-premises to AWS. And we already talked about NFS or SMB file shares, about object stores that supports S3 API or Hadoop clusters that you need to move data from on-premises to AWS. So in that case, you need to deploy an agent. So an AWS Data Sync agent is a virtual machine appliance that you deploy into your preferred hypervisor. And today we support VMware, KVM, as well as Hyper-V. So once you deploy the AWS Data Sync agent, it will connect to the Data Sync managed service that is running on AWS. And this managed service will take care of copying the data from your on-premises systems to AWS, and it will provide all the needed connectivity. And of course, when you will copy your data, it will be fully encrypted and secured. And in that particular case, you can choose between 3 connectivity endpoints. So the first one is that when you want to use a private connection from your data center to AWS, either leveraging a virtual private network or VPN or AWS Direct Connect, so that you have a private connection between your on-premises storage systems and AWS. And for our customers who don't have this type of private connectivity, and they are comfortable to use the internet to move their data, they can use the public endpoints. And in addition to that, for our customers who are moving data to US government agencies, they can use what we call a FIPS endpoint to have this extra compliance. And if you are moving your data from AWS storage services, so we talked about moving data between, for example, Elastic file systems to an Amazon S3 to archive it, you can use data sync without having the need to deploy an agent. So you don't need to deploy this extra infrastructure, and the data sync fully managed service will take care of moving the data between those services. And the cool thing is that you will leverage the AWS backbone. So you are sure that your data won't leave the AWS network, and you will take profit from the high availability and security of the AWS network. So we talked about how you can use AWS data sync, but how does all of that work? So as we discussed, the first thing is to ask yourself, do I need to deploy an agent, and where? And you don't need to deploy an agent, as we discussed, in case you are moving data between AWS storage services. So in case, for example, you are moving data from your Hadoop cluster, you need to deploy an agent. And as discussed, this agent is a virtual machine appliance that you will deploy into your hypervisor. So once you deploy the agent, it will connect to the AWS Data Sync Managed Service. And you need to create locations. So you need to create source and destination location. And this concept of location is used by data sync to move the data from the source and destination. And a location in data sync could be either one of your on-premises storage system, for example, NFS file server, or it could be one of the AWS storage services that we provide, like, for example, an Amazon S3 bucket. So once you create your locations, you need to create a task. And a task consists of a source and destination location. And the AWS Data Sync Managed Service will take care of running the task and copying the data from the source to the destination location. And as discussed, in case you are moving your data from on-premises to AWS, you can leverage any of the connectivity endpoints that fits your needs, So we discussed about the public and private endpoints, as well as the FIPS endpoints. And now I wanted to discuss one of the use cases, interesting use cases that our customers are using with AWS Data Sync. So in case they want to move their data from their Hadoop clusters to AWS and make this data available to be processed with either our data and analytics services or machine learning services, as well as big data services like EMR, so they can gain insights quickly into their data. And in this particular use case, I wanted to share with you one of the use cases that leverage AWS Data Sync in this example, which is Team Up Mobility. So Team Up Mobility is one of Korea's leaders providing a mobility platform to millions of end users, and they rely on a Hadoop cluster on their data center to provide analytics and processed data to their end users. And in fact, when we started the discussion with Team Up Mobility, and they, in fact, were interested in using EMR because they were impressed about how it is easy to run Hadoop platforms on AWS, they decided to move their data from on-premises to AWS. And they needed to move 2.4 petabytes of data only in 2 months. So it was really very tight deadline. So their data intelligence group started thinking about how to move their data, and they explored both online and offline migration strategies. And as they already had a 10 gigabit per second direct connection to AWS, and they were not very familiar using hardware devices, as most of the team were consisted of developers, they decided to use AWS data sync to move their data. And they succeeded moving those 2.4 petabytes of data in 2 months, relying only on 2 developers that had no much experience with AWS data sync. So they were successful to meet the tight schedule for their migration project, as states their data intelligence platform leader. So with that, I will leave you with Eric to discuss AWS Now family.
Thanks, Miriam. So as Miriam mentioned, I'm going to talk about the AWS Snow family and then wrap up the end of my section with talking about specifically how you can use it and best practices for large-scale data migrations. So to start, what is the AWS Snow family? And so the Snow family is a service, a managed service that consists of physical devices that we ship to your premises, wherever you specify. In the case of large-scale data transfer, that's typically your data center. But they've also been designed that they can be sent to austere locations, put into vehicles, as Miriam alluded to, a number of different use cases as the devices are all ruggedized. So the devices come in a different capacities and actually different form factors, as you can see. There's the smaller snow cone device, which is roughly like a tissue box sized device, and then the larger snowball edge device, which is about the size of a suitcase. If you made it down to the expo at all, you might have seen snowball devices. We had and snow cones. We had them in a number of different demos and places all over, including the basketball hoop simulator in the middle of the hybrid stage. So one of the things that is unique about Snow in terms of data transfer is the service is, as a managed service, we ship you these devices. Not only can they be used for just for bulk data transfer, but they can also process your data at the edge, having a meaningful impact of the amount of data that you need to bring to the edge. Perhaps you can pre-process some data before shipping it to the region. And they can accommodate a wide variety in terms of the capacity that you need to transfer. As you see alluded there with a snow cone, you might be transferring less than a terabyte or around a terabyte from many different locations, a highly distributed workflow, or you might be doing a large-scale data center migration in which you need to move tens of petabytes, if not more, and you'll use clusters of Snowball Edge devices. So Snow really serves 2 purposes. Our original purpose of the service, when it first launched back in 2016, if I recall, was for offline data movement, right? We had customers coming to us and saying, we need to move petabytes of data out of our data center. We want to move into the region. We're all in, or we're shutting down old storage arrays. And so we created the device as opposed to customers having to, you don't need to go and purchase your own hard drives that then you would ship to us. Instead, we would send you the devices that would allow you to securely transport your data and bring it into AWS, without having to go through the capital expense of buying that hardware for that one-time use. And so I'll get into the specifics of it, but the service is designed all about security, right? So it can be, you can accomplish those data center transfers either offline, which is the most common use case if I were used, but there's also some means that you can also use it simultaneously online, which Miriam's going to talk about at the end of the presentation. The other use case that we've evolved into, which isn't the focus of today's discussion, but I'm going to mention it in terms of the service, is the rugged edge computing the rugged edge compute use case. So we bring a select set of AWS services out to the disconnected edge. that allow you to do that data processing, run applications out at the edge where needed, and then have that data stored onto the Snow device, where at time that workload or that data set's ready to be brought back to AWS, you can perform that compute at the edge and bring it back to the AWS region. So our key value propositions for the service are, of course, offline data movement. So we provide the physical hardware that you need to migrate data when you have limited bandwidth, or perhaps bandwidth's practically non-existent. We can accommodate a variety of scenarios on that front. And as I mentioned, security, like everything at AWS, is job one for us. So there's a number of measures that we take with the service to accommodate, in terms of security. Each device, and I'm going to show some screenshots of them in a second, but each device is built into a ruggedized enclosure, and that enclosure is tamper-resistant, but also has tamper-evident seals. So when you get the device on site and you ship it back to us, we receive the device in special dedicated rooms with secure personnel that inspect those devices to make sure that nothing's been physically compromised. We also, all data written to the device is written with 256-bit encryption, and those encryption keys are managed by you, the customer, using the AWS key management system, or key management service, or KMS. And then finally, we use a industry standard chip, if you will, called a trusted platform module. And what a trusted platform module, or a TPM, does is it creates a hardware root of trust on the device, and that it's actually inspecting the software, the firmware, and the hardware to ensure if any sort of tampering's been done, electronic or otherwise, that we're alerted and we know that that device has been compromised and would not import your data. As I mentioned, the service is designed to be run partially or fully disconnected. So we have this term we like to use. It's actually, I think we borrowed it from the US military, called DDIL, or DDIL, which is you're either in a denied, disruptive, intermittent, or limited environment. So if you're, say, in a military situation or a defense situation, you might be able to you would bring Snowball devices in to transfer data from a place where you're in an air-gapped scenario where you actually can't have external network connectivity. You might be in a place where you have limited connectivity, right? You might be operating over 5G or 4G, or you might just have an old network with, that's highly latent. And Snow devices are designed to be scalable. So as I mentioned on that first slide, right, you might be doing a wide distributed data collection and then import into AWS 3 using many, many Snow Cone devices. But you also might be doing a large-scale data migration where you're taking tens of petabytes of data, and there you can build a storage cluster of Snowballs on-premise temporarily, and then ship those devices back to AWS to perform that large-scale data transfer. And then we provide AWS compute services and capabilities at the edge. So on the Snowball devices, we provide core services like EC2 for compute, EBS for block storage, S3 for object storage, and then, of course, for security, IAM, and even a number of AI and ML services to allow you to do that lightweight data processing out at the edge. And in bringing those services to the edge, and I should emphasize to the disconnected edge, it doesn't require you to be connected to the region to use those services. We ensure that the experience that you have as an edge developer and as an edge operator is consistent with the experience that you have when using the services in the region with compatible APIs. So this is the Snowball Edge. This is the suitcase-sized device. And so it comes in various configurations that you can order that either go from being compute optimized or to storage optimized configurations. So we actually just recently refreshed the compute optimized version of this about a month and a half ago. And the compute optimized version, well, let me back up. The varieties you can get it from come from 32 up to 104 virtual CPUs, so quite a bit of compute. We just added that 104 vCPU model, paired with 208 up to 416 gigs of RAM. The newest model, the compute optimized model that has the high end of those compute specs, comes with 28 terabytes of NVMe storage, so highly performant SSD storage on the device. And the storage optimized model, kind of more of the bulk data transfer model, currently comes with 80 terabytes of spinning disk. And then to accommodate not just compute workloads, but of course the sheer amount of data in a bulk data transfer, we can accommodate up to 100 gigs networking with a Mellanox CX5 interface built into every Snowball Edge. I mentioned the tamper resistant and tamper evident. As you can see from the picture of the device, it's designed to be rugged. And so in terms of being rugged, it handles up to 200 Gs of impact. These things are air-droppable. They're used in defense use cases. We've gone through a number of different testings. You can find some fun videos of us online actually exploding the device or putting it in subject to explosions and it withstanding those impacts. We do meet a number of military specs. So MIL-S 901D is a mil-spec standard that we meet for the customers that need that. We also support FSMA High, FedRAMP ITAR, CGIS, and DoD SRG level 6 requirements if you have those sorts of environments. And while the device absolutely can be used in the data center and is often used in the data center for these large-scale data migrations, it's designed to operate on unconditioned power, right? So this thing does not need to be in a data center. It's designed to operate on its own in any sort of austere location that you might bring it. And in those non-data center environments, we can withstand freezing, right? 0 degrees Celsius up to 45 degrees Celsius without any additional enclosure needed in the device, just running on its own. And as I mentioned before, all data that's written to the device is always secured with 256-bit encryption. And because we're sending these things out to the edge and even the disconnected edge, it's been designed to be operated by non-technical personnel. So there's a CLI that you can operate every device. There's even an SDK you can develop against. But in terms of just these edge operators, we have a GUI, which I'll show a little bit about and talk about, that is designed to allow you to operate, to configure and operate the entire device, including your data transfer. And then finally, it is designed to be handled by a single person weighing in at 49 pounds. And so this is the smaller sibling of the Snowball Edge. This is the snow cone. And so this has really been designed for more mobile type workloads. It's, as I mentioned, kind of a tissue-sized box. Its capabilities are a bit more lightweight due to its size and the types of workloads that customers are using it for. It features 202 virtual CPUs and 4 gigs of RAM, and then it comes in either a spinning disk version with 8 terabytes of spinning disk, or a SSD version with 14 terabytes of SSD, and it can support either 1 or 10 gig networking. Same tamper-evident, tamper-resistant design that's in its larger sibling, and goes through all this exact same security processes. This has been designed to handle vibrations up to 50 G RMS. Why that's important is these things are kind of designed to be used in vehicles of all different types, so they can work for these highly distributed data collection workloads. Same power conditions, unconditioned power. In fact, what's interesting about the snow cone, different than the Snowball Edge, is the power on it is actually just a standard USB-C port. And so you can connect that via any USB-C interface you have. And there are customers, too, who use these, again, in totally disconnected environments and just hook them up to batteries and can operate the environment completely remotely with disconnected power as well. And then same 0 degrees to 45 degrees Celsius. 256-bit encryption, exact same procedures here as you find on the Snowball Edge with the same GUI that I'll talk about. But this weighs just 4 pounds, and it really was designed to put into a backpack. So it gets used by disaster response personnel, forward deployed personnel in defense use cases. In media and entertainment, we have customers that use these snow cones to go and capture video footage out, right? That then bring it back for post-processing in the cloud. In industrial IoT, right, so think factory IoT with smart robots, customers are deploying these for lightweight compute and data collection for the telemetry off of those devices on the factory floor. And then finally, Miriam already mentioned this one, but in the automotive use case, the automotive companies for autonomous driving systems are using these to do data collection and then be able to bring that telemetry data back to the cloud for processing. So these are the services that we support on the Snow family. If I group them, kind of at the bottom, you have sort of your fundamental edge infrastructure type services. And then in the top right, you have your AI ML services. And on your top left, you have your more data transfer and, of course, security fundamental IAM service. So specifically what we support on the edge infrastructure side is an EC2 compatible API. Again, that cloud consistent experience for operators and developers at the edge as to what's being done in the region. We also have an EBS compatible API for block storage for running your local workloads, an S3 compatible adapter API that enables you to also store local S3 data for your data transfer purposes and manage buckets locally on the device. It comes with NFS storage, local NFS storage for storing file data. And it currently runs the Amazon EKS distro, so you can run containerized workloads on both Snow devices. In terms of AI/ML, we support IoT Greengrass. So IoT Greengrass will actually allow you to run Lambda functions out at the edge if you want to go even lighter weight than a container, and as well as services like IoT Sitewise Edge and SageMaker Edge, where you can run inference models out at the edge. And then finally, data transfer. We support S3, of course, as I mentioned, which is probably the most common use case, NFS for data transfers for files, and then Tape Gateway on Snow. So this is a very specific use case where customers are trying to migrate off of their legacy tape backups, and they're able to use the Snow devices to actually virtualize those tapes and then bring them up to, say, Amazon S3 Glacier for long-term storage. And then, of course, we also, as Mary mentioned, we run the data sync agent, so you're able to initiate online data transfers from the device in those data collection type scenarios. This is Ops Hub. So Ops Hub is that graphical user interface that I was talking about that can be used to manage the devices. So it's not required. As I mentioned, there is a CLI and there is an SDK if that's the preferred operating model, but this is by far the most popular. This is installed locally. So the control plane of the device is entirely disconnected from the region. You run it entirely local in your environment, no connectivity required. And what Ops Hub allows you to do is to first unlock the device, configure it, and then you can do all sorts of things in terms of managing a single device or even fleets of devices. You can have a single pane of glass of seeing what is the current storage, compute, memory utilization of each device. You can, with a few clicks, set up your local NFS shares and actually drag and drop files from your workstation into the Ops Hub console to store it on the device. You can even, if you preload AMIs, Amazon Machine Images, when you order the devices, or you can do a thing called sideloading them when they're received on site, you can even stand up the EC2 instances to attach those AMIs to boot local compute instances on the device, all in Ops Hub. So, specific to the offline data migration use case, kind of the foundation of where the Snow service started, I want to talk through what is sort of the workflow that it looks like from when you're ordering a device to copying a device and receiving it. On average, most of the steps in this timeline take about 1 to 3 days, but there's 2 exceptions to that, where it's the time that it takes to copy the data onto the device and the time that it takes to copy the data off to the device when it's received by AWS. And the reason those are variable is there's just a whole number of different considerations about what impacts the amount of time to copy to and from the device, and I'll talk about that. So you order a Snow device from the console. You just go into the AWS console, go into the Snow family service, tell us the device types you want and how many, and where to ship it to, and then that creates what we call a job, and the job is the use of a single Snow device. We then ship the device to you, we then provision the device. You also do things like tell us what S3 buckets you want to be importing data to and a few other steps. And then we'll provision the device, and that typically will get provisioned within 1 to 3 days, depending on the region and the current availability and things like that. And then depending on the shipping speed you select, that's either 1 to 2 days. That goes just through a standard third-party courier. Here in the US, we use UPS, for instance, but we have partnerships all over the world where we support the Snow service. Then when you receive the device, you either use that CLI or Ops Hub to connect the device to your environment. If in the case of data migration, create a staging workstation, something like that, or a local laptop, and then you start copying data onto the device. That is the variable part, because there's considerations in terms of what is the performance of your local network, right? How direct of a connection do we have? What is the speed of the source of the data? So say your storage array or your existing on-premises servers, those can all limit the amount of time that it takes to be able to transfer data onto the device. And then there's considerations around things like the size of your files. So let's say you have many, like millions of very small files being less than a megabyte in size. Due to the nature of the copy operation, that can actually take a lot of time, that can add a lot of overhead to the operation. So I'll talk about some ways to mitigate that. Once that transfer is done, you simply power down the device, and that e-ink display you saw on the device actually updates with return shipping label, and you just hand it back to UPS, and they bring it to us. Once we receive it, again, that's just whatever shipping time you specified. Once we receive it, we do that tamper inspection. We receive it at one of our ingest rooms, And then we'll go in and begin to copy the data off of the device. Again, that's a variable amount of time depending on the file sizes and the like. And then once we're complete, you'll receive a notification in the console that your data's been transferred to where you specified. And then we erase the device using a secure erasure process that complies with the NIST 800-88 standards. So I want to talk about customer example. So Join is Germany's first free video streaming service, so think like a Hulu here in the US. And they were facing a challenge where they were looking to shut down their on-premises data center due to their infrastructure coming to end of life. But they had a 3-month migration goal in order to meet that, or 3 months to accomplish that goal. And due to limitations in their bandwidth and current network configuration, they really needed the increased flexibility and availability of just having the device, being able to do a physical local copy with Snow. So they chose to use multiple Snow devices. They used the storage optimized device and built a local storage cluster where then they were able to do a bulk transfer using multiple devices on a rotating basis. Where they were sending the data to was into S3 intelligent tiering. So S3 intelligent tiering allowed them to optimize their storage costs as their warmest data stayed in the warmest storage tiers, and their coldest data, their least frequently used data, went to colder storage tiers at a much lower cost. So they were very successful. It was a very well-managed transfer. They moved 3.4 petabytes in just 90 days. That's resulted in a $500,000 a year $500,000 savings per year by closing that on-premises data center with no increase in their total cost of ownership. And so their media engineer said that moving our archive using AWS Snowball Edge was fast, simple, and secure, but we're also impressed by how cost-effective it was. So now that all their content is easily accessible in S3, they're able to quickly transcode and deliver their content to audiences that they can't find on any other streaming service. So the last consideration here is best practices for managing these large-scale migrations using Snow. And we've done migrations from customers from Photobox to Netflix, and so we've really come down to sort of here's the key steps that you need to take. And I can tell you the most important step is to run a proof of concept. Because running a proof of concept is going to allow you to discover any potential issues or limitations in your environment. Things like network congestion, limitations on the source of the data, or those small file problems that I was talking about, or limitations. Deploy dedicated staging workstations, right? This ensures we're not competing for resources when we're trying to transfer data onto the Snowball device. And then batch small files, like I talked about. If there's files less than 1 megabyte in size, you can aggregate those files, put them into a tarball. There's scripts available online. There's all sorts of means of doing this that will allow you to, during the staging of the data onto the Snowball device and bringing it into the region, will greatly expedite the amount of time that it takes if you're in that situation. Your benchmark or optimal data transfer that we've seen across this large swath of customers is typically about 300 megabytes per second to 500 megabytes per second that you should sort of expect. And what I strongly recommend too is if you're in these multi-petabyte transfer scenarios is reach out to your account team. If you have a TAM, your technical account manager, get your technical account manager involved because they can work with us on the service team side to ensure we have the right devices available in the right regions in the sort of time frames that you need so we can have a very optimized experience in terms of getting devices to and from AWS to accomplish it in the time you need. Last, we did earlier this year, in April of this year, we launched a new feature in Snow called the Large Data Migration Manager. And so this really takes a lot of what I was just talking about, these best practices, into managing this overall data transfer when you're using multiple devices to accomplish a transfer that requires multiple devices to be accomplished. So it's a planning tool, and it's also a management and monitoring tool. What it allows you to do is you go into the tool in the console, you tell us the overall amount of data that you need to have transferred, tell us the location, where we're transferring to, all those sorts of things. And then you're able to create your jobs, and remember jobs are individual Snow devices. You're able to create your jobs in there in one pane of glass, and you can clone them. So if you're using multiple Snow devices for one location, you don't need to take the time to recreate duplicate jobs. And then for every job that you create using this management tool, you're able to monitor the status of that transfer. So you can see, is it in the shipping stage? Has it been received at your site and it's ingesting data? Has it been received back from AWS and are we uploading data? And when is it completed? And that gives you sort of that real-time insight and that project management of the overall experience. So with that, I'm going to hand it back to Miriam to talk about using Snow and Data Sync together.
Thank you, Eric. OK, folks. So let's do a quick poll. Who would go with AWS Data Sync to move data into AWS? OK. And who would use the Snow family devices to move data into AWS? OK, so sometimes the answer to which service I need to use to move my data into AWS is not so easy to answer. But we hope that we provided you with some clarity to help you pick the right service to move your data into AWS. But in some use cases, our customers would need to leverage both services to move their data into AWS. So you can think about the critical application data that you need to move, or the critical database that you need to copy into AWS without having any downtime or with a very little downtime. So in that particular case, you can use the Snowball Edge devices to move your data. So you perform the first bulk copy to AWS using the Snowball Edge devices. And once the data is copied from the Snowball Edge devices into AWS, and once you verify that all the data is copied to your Amazon S3 bucket, you can leverage AWS Data Sync to perform the incremental copy. So you can copy the data that has changed or that was added to your on-premises storage systems. And AWS Data Sync has this intelligence to check which data has been changed and to pick up only this data and copy it into AWS. So in that case, you don't need a huge bandwidth, to use a huge bandwidth, and you can perform the incremental copy. And once it's done, you can cut over the service and migrate your workload into AWS. And another use case, so we already talked about using AWS Data Sync with a Snowcon device. So in that particular case, you will activate the AWS Data Sync agent on the Snowcon device and use the NFS interface to copy your data into the Snowcon device. And for example, you can think about the media companies who have a shooting outside, so a video camera shooting outside. So they can bring the Snowcon devices on the shooting location and copy the data into the Snowcon device. And once they finish, they go back to their office, plug the Snowcon device into their network, and copy the data to AWS for further processing. So those are some use cases that you can leverage, or that can give you an example about how you can use both services together. And with that, I want to wrap it up and leave you with 4 key takeaways. So first, when planning your data migration project, you need to evaluate which goals and resources you have. So for example, you can think about how much bandwidth is available for you to move your data online, or how much resources in terms of engineers you have to move the data. And also, you need to think about the timeline. This is really very important. So all of that will guide you using between online or offline migration strategy. And of course, sometimes you need to combine both. Sorry. And to choose the right migration strategy, you need to make a separation between archive and production data because the goals and the constraints are not the same. So to move your archive data, you can do it offline. You might don't have a tight timeline to do it. So versus production data, sometimes you need to move critical application data or critical databases, and you need to move really very fast. And once you identify the migration goals and the migration strategy that you go for, you can leverage multiple tools and resources. And of course, you can leverage your AWS team, and we are more than happy to help you with your data migration projects. And you can scan these QR codes to access DataSync and Snow Family product pages where you can find valuable resources like blog posts, video demonstrations, or customer use cases. And we have additional sessions, either live tomorrow, or you can access the replay for our DataSync sessions. And if you want to dive deeper and continue your AWS storage learning, you can build a learning path plan using AWS Skill Builder, and you can also earn our AWS storage badges. So with that, with Eric and Randy, we want to thank you for your time and your attention. And please fill the session feedback using the mobile application. And if, in case you have any questions, please come to see us, and we will be more than happy to answer your questions. Thank you.